Good morning, students. This is Deepika Lona, your IT teacher from Cambridge International School, the SUA. I'm once again with you with a new tutorial. So let's start with today's class. So in a last tutorial, we discussed about data types. In today's tutorial, we will just do a recap of all the tools about database, whatever we have discussed about database. So we will discuss about what is database and what is DBMS, what is table, what is record, what is column. Then we will also discuss or recap about database keys, primary key, foreign key, composite key, compound key, super key, all these keys which we have already discussed. Then along with this we will discuss about data types also. So just recap will be done today, and so that we could go through that all the concepts are clear to us or not. So let's start.
Hi, my name is Mo. Today, I'm going to present to you Introduction to Database. I'm sure that you have heard data before, but what is a database? Database is a collection of data. As an example, student identities and company statistics. Data consists of raw facts. In order to transform data into useful information, it must be organized in a meaningful way. This is key field, such as student identity numbers, and these are attributes, which is also field of the database. While these are the entities, which are also the records. We are going to learn about two things. What is DBMS and what is DBA? Database Management System, which we also call as DBMS, is a group of programs that manipulate the database. A DBMS provides an interface between users and database to ensure that data is consistently organized and remain easy to access. There are two types of database software, which is single user, which means only one person can use the database at a time. Multiple users allow dozens of hundreds of people to access the same database at the same time. There are a few examples of database software: MySQL, Oracle Database, Microsoft SQL Server, and Sybase. A DBMS provides users and programmers with a systematic way to read, update, create, and delete the data. Database administrators, and also DBA, is a group of professionals that use specialized software to store and organize the data. Their job scope include capacity planning, database design, migration, backup and data recovery, installation, configuration, performance monitoring, and security management. DBA directs all activities related to an organization's database. Without DBA, an organization could not successfully complete most business activity. Nowadays, databases are widely used in banking and finance, business organization, education, manufacturing. Thank you for watching. See you again.
Tables may be the foundation of your database, but you need something to hold them up. Columns. Every table in your database will have at least one column. Each of these should hold values for one aspect of the objects the table stores. For example, I've got my table of toys here. and each toy would be a row in the table. Now I might have columns to store things like the colour, the weight, and the cuddliness factor. When you're creating columns, there's two things you need to decide: what to call them and their type. When naming columns, call them something meaningful. For example, I could call these Jeff and Bob, but that doesn't tell me what information they hold. Better to have boring names like colour, toy name, and so on. Otherwise, it just gets confusing. Far more important is to choose the correct type for your columns. Get this wrong, and not only will your tables look silly, you'll never be invited back to Architects Club. But most importantly, your tables just won't stand over time. Wrong data types can lead to all sorts of unexpected errors and performance problems. So let's look at common data types and when you'd use them. Numeric columns store things which are, well, numbers. For example, the price of a toy, its size, weight, and so on. Oracle Database has several predefined numeric types. Each have different precisions. Choose the appropriate type based on the data you want to store.
No, not this kind of date. Calendar dates.
These store when something happened or is planned to happen. It's really important that you use data types when you do this. Not numbers, not strings, dates. Dates are stored down to the second. If you need to be really precise, check out timestamps. These go right down to nanoseconds. And timestamps allow you to do something that dates cannot: store time zone information. This is great if your colleagues work in different parts of the world.
It's 1 in the morning.
One 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 010110 0111 010 0111 010. Block. Strings hold general purpose text, descriptions, names, or your innermost thoughts. You can also use these to store unstructured data. The primary data type for these is varchar2, but if you're storing huge amounts of text, use a clob.
Bob is adding some information to his linked tables. Some of his customers have an allergy to peanuts. Bob can add a field to his sweet table to store if a sweet contains peanuts or not. This is a special type of field because it contains values which can only be true or false. There are only two possible values in this type of field. Fields that can only store true or false values are called Boolean fields. They have a field type of Boolean. Bob also has a website where he has a different page for each category. He can add a field to his category table to store the web address of each of these pages. A field that can store a URL or a uniform resource locator to give it the full name is a field of type link because it stores a web link. Bob adds the field web page to his category table using this link type and adds the addresses of each of the category pages. Very cool. Now he can just click on the link in his database software to open a web browser and view the web page. The fields in Bob's database have a specific length or can store a specific range of numbers, dates, times, or characters. The name field of his suite table has a field length of 40 characters. So the field cannot store more than 40 characters. If Bob was to enter 41 characters, he would receive an error message from his database management software and be told to try again. Giving fields a maximum size is a good idea because your database management software can then use only the storage space it needs for the fields, rather than trying to guess how much it might need. It also puts some limits on how long the contents of your fields can be, which is normally a good idea. Would you really want a suite that had a name that was 100 letters long? Having fields that have a range is also a good idea. Bob sells his sweets in bags of different sizes depending on the type. So, for example, his English toffee is sold in a bag containing 10 toffees, and his cola cubes are sold in a bag of 20. The largest bag contains 25 sweets, and the smallest just 5. The range on the field bag size is from 5 to 25. Bob is really happy with his database of linked tables. He has linked it to the till in his shop so that when he sells some sweets, it gets updated automatically. This means he can see which sweets are the most popular, which sweets he needs to restock, and which sweets also make the most profit. Bob's database helps make his business better. So, some things to remember. A table in a relational database is a collection of information. Each record is about one thing in the collection. Linked tables are 2 or more tables in a database that share a key field. The value of the key field is used to link the 2 tables together to provide more information. Link and Boolean are 2 new field types which we can add to the 6 we already know. Fields of type link store uniform resource locators, URLs, the web addresses we use to find web pages. Boolean fields store values which can only be true or false. Text fields in a database can have a specific length. This is the maximum number of characters that the field can store. Some fields can also have a limit put on the range of numbers, date, time, or characters they contain. This restricts the data in these fields to within the range. For example, numbers from 1 to 10 only, or dates from 1st of January to the 31st of March only.
Hello friends, and welcome back to Study Tonight's YouTube channel. In this video, we will talk about DBMS keys. Students are always confused about this concept as there are many different kinds of DBMS keys and almost all are related to each other with a slight difference, which makes it very difficult at times to get a clear understanding. In this video, we will learn what are database keys, why we need these, and the different types of the DBMS keys. A database key or a DBMS key is an attribute or a set of attributes which help you uniquely identify any record or row of data in a table. Let's take an example. In the table above, we have SID, SNAME, SBranch, and SEmail as attributes, saving details about students. If I ask you to tell me email address of the student with name Adam, Can you tell me? No, because there are 2 students with name Adam. Or if I ask you, tell me name of student who is in CS branch. Again, there will be many students in that branch. But if you look closely, SID column has unique value for all the rows of data. And the S-email column also has unique email addresses. Hence, these 2 columns can be used to identify records in the above table. So we can say that SID and S-email are keys for this relation. This brings us to the question, why we need keys. The first reason is pretty much obvious. Without a DBMS key, you cannot access the rows of data stored in the table uniquely. Because without a key, most of the time you will either receive multiple rows of data or incorrect rows of data. Another big reason, which is kind of an extension of the first reason, is we can force identity of data and ensure integrity of data is maintained using DBMS keys. By making an attribute a key and making it mandatory, we can enforce that anything inserted in the table is identifiable, hence ensuring data integrity too. And last but not the least, we can establish a relationship between tables using keys. It's time for the main event, types of DBMS keys. There are 8 different types of DBMS keys, of which super key is like the default key, and composite and compound keys are like cousin sisters. We'll see when we learn about them. So we will be starting with super key, then we will move on to candidate key, then primary and alternate keys, then the foreign key, which is different from all others and serves a purpose which none of the other keys do, and then we will cover the remaining keys, which are composite, compound, and surrogate. Super key is nothing but a key. It is a superset of keys in which all possible keys are included. Like in our example, SID, registration ID, email, then combination of them, SID, registration ID and email, email and SID, and then all 3 together, SID, registration ID, email, all are super keys. There can be more as well. In simpler words, an attribute or a set of attributes that can be used to identify records in a table is a super key. Then comes candidate key. It is the minimal set of super key which can be used to uniquely identify rows of data in a table. We saw that we have so many options for super keys, but most of them are formed by unnecessary pairing of keys, like email ID, SID, registration ID together as a key, or email SID as a key, when email SID and registration ID can individually uniquely identify a row of data. Hence, in this case, the 3 attributes SID, email, and registration ID, or reg_id, are the minimal set of super key, hence the candidate keys. Speaking books language, if any proper subset of a super key is a super key, then that cannot be a candidate key. Now let's try to understand this. Registration ID, email, and SID together form a super key, while email and SID is a proper subset of it and is also a super key. Hence, this is not a candidate key. Similarly, email SID is a super key, and its proper subset, email and SID, both can act as a super key individually. Hence, this is not a candidate key. This way, we can come to a conclusive proof that SID, email, and registration ID are the candidate keys for the relationship that we have. Now, moving on to primary and alternate keys. A primary key is a candidate key which is used to uniquely identify every row of data in a table. Now you must be thinking that we have 3 candidate keys and all of them can do so. Well, in that case, you can make anyone a primary key. This is generally done by database administrator to set a candidate key as a primary key. If we have to create a simple user interface to search for student information for our college using the table in the database that we have as an example, what will make more sense? SID, which is an auto-incremented value by the database itself, or registration ID, which every student knows and is more meaningful for college administration too. Hence, in this example, we can make reg_id or registration ID as primary key. All the remaining candidate keys which are not selected as a primary key are called alternate keys. Now, coming to foreign keys. Foreign key is nothing but an attribute in a table which is used to create a relationship of that table with some other table. In case our tables have relationship, using foreign keys helps us to maintain data integrity for the relationship. For this, we will have to involve another table in our example. Let's say we have one more table, branch, with information about the branches in the colleges. It has a unique column with branch code, branch name, HOD, and some more branch related information. In the students table, the branch code can be made a foreign key to set up referential integrity or relationship between the table student and branch. This way, while making a new student entry, a wrong branch name cannot be provided, else a DB will return error. Similarly, if someone deletes a branch entry or updates a branch code in branch table, they will have to change the same in students table too. Generally, this is not allowed by the database, and the database returns error when someone tries to modify the column value which is used as a foreign key in some other table. Hence, this way we can force integrity of data in a relationship using foreign keys. Moving on to the remaining keys, a composite key has multiple attributes. Hence, all the super keys with more than one attribute are also composite key. In our case, email SID together, SID registration ID together, registration ID email together, all are composite keys. If a composite key has one attribute which is foreign key, then it is called a compound key. Moving on to the surrogate key. Sometimes a relation or a table has no attribute which can uniquely identify the rows in the table. In this situation, when there is no natural primary key, we create an attribute to act as a primary key, that is a surrogate key. These keys do not add any meaning to the data, but serves the sole purpose of identifying the data. With this, we have covered all the DBMS keys, starting from super key, candidate key, then primary key, alternate key, foreign key, composite and compound key, and surrogate key. I hope after watching this video you have a better understanding of what DBMS keys are, why they are required, and the various different types of DBMS keys.